This is problem number 6 from the projectile motion handout. The question is, Jack be nimble, Jack be quick. Jack jumped over the candlestick with a velocity of 5 meters per second at an angle of 30 degrees to the horizontal. The question is, did Jack burn his feet on the candle if the candle is 0.25 meters high? In other words, what is Jack's maximum jump height? Or what is the delta x, the range in the y direction? So if we were to sketch or diagram this out, we can label the following. We know that as Jack jumps over the candlestick, his velocity is 5 meters per second. Okay. We also know that it is at an angle of, or theta is equaling to 30 degrees. The question that we are asking is, what is, or find delta x in the y direction? We first have to solve or find velocity in the y component. In order to do so, we know that velocity in the y component is equaling to sine of theta, which also equals to the opposite over the hypotenuse. If I rearrange this formula, I can say that h sine of theta is equaling the opposite side. Sine of 30 is equaling to the opposite over the hypotenuse. If I just solve for my formula here, I know that hypotenuse is equaling to 5 meters per second, sine of theta, which is 30 degrees. That means the opposite, the velocity in the opposite direction, is equaling to 2.5 meters per second. For part 2 of this problem, we need to find delta x in the y direction. We're going to use the formula of v1 squared is equaling to v naught squared plus 2a delta x in the y direction. We know the final velocity, that's this right here, which we just calculated to be 2.5 meters per second. And this is squared, is equal to the initial velocity of 0 plus 2. A is equaling to gravity, or 10, and delta x in the y direction. Through solving this formula, we find delta x in the y direction to equal 0.31 meters. 0.31 meters is higher than 0.25. Therefore, Jack will not be burned.